Okay, so I'm going to start to introduce my strategy, which is the basic Avellaneda Stoikov strategy. First of all, let's talk about how does it work. So, like in the simple PMM script, like this is a simple pure market making script. We just have two variables, which is the market price and the spread set by us, and then we just buy low and sell high based on these two variables. So in this AS model, AS strategy, like we just have two like fancy words, like which is the reserved price and the optimal spread, and these two are just different versions of this market price and spread set by us. So like basically it just means like price and spread, like to adjust it to deal with the inventory risk. Yeah. So let's talk about a little bit about inventory risk. So as a market maker, we don't like trend, right? Because if there is a trend, like especially if it downwards, like it really sucks. Like this is an example. Like there is a bad coin, which is made up by me and the USDT market. Like if this price keep going down, and this means like our USDT is going to be lost because we're going to buy a lot of bad coins, like without selling any of them, right? Because this is a downward trend, and our buy orders tend to always be filled, and the sell orders will not be filled. Yeah, and we'll end up with a lot of bad coins here, like over here, like without any USDT left in the most extreme case. So like how to deal with this? Like it's pretty simple actually. Like we just need some mechanism so that when downwards trend happens, we just don't buy that much like bad coins. Like this is bad coins like or BTC. And they're the same. I just use like cryptocurrency. We just don't buy a lot of them when their price is going downwards, especially when there is a trend over there. So we just like in this AS model paper, there are two variables, which is the reserve price and the optimal spread, like which is shown here. So I will not read out these formulas, but I will definitely like uh, to make it more clearer, make it clearer to about the variables. So like the S is current market mid price, and basically it's just the price in the PMM script, and Q is the inventory position deviation. I will explain all of them later, and I'll just say like this guy will be calculated based on like current and target inventories, and the gamma was set by users, and sigma is fetched from source, and T minus T, which is time to the end of market, like this is set to be a constant because like I'll also bring up about the reasons later. The optimal spread, there is only one new variable, which is the kappa, which is denoted by K here. Like this is the order book liquidity, and this is also set to be a constant. Okay, the conclusion is just Q, which is the inventory position deviation, will be negative if you want to buy more, and positive when you want to sell more, higher when you are farther away from target inventory, lower when you are near to the target inventory. And gamma is set by yourself, like sigma is decided by market, so we can't do much about it. T minus T is a constant, K is also a constant. So, yep, let's run it. Okay, so we run it for 1 minute, and as you can see here, like if you pay attention to the price changes, it seems that the reference price is not changed. Like it's always the same as the original price. But I think that's because like the adjusted parameters are too small, so that they are not able to like adjust the reserved price properly in like to make it significant. Like that's also my next step. So the for the future, like I will have a better understanding of the paper. So maybe solve some PDEs, and it seems quite interesting. And I'll find better ways to represent the parameters, like which also relate to the questions, like the problems I'm faced now. So I also make this classic model more complex based on other papers or methods, just as Hamilton did um, in its previous version of this model. Yep. So I think that'll be all. Thank you very much.